Lesson 7.2, ellipses and circles. Here is given the standard forms of equations for ellipses. This right here would be considered a horizontal ellipse because the a term here is always larger. Whichever of the terms is larger. If the term is larger under x, it's horizontal. If it's larger under the y, it's going to be vertical. So they just have a representing something bigger than b. And so if this number is bigger, since it's under y, this will be a vertical. This would be horizontal. How we determine this stuff, a refers to, I know this shows a squared, but a is the distance from the very center to the left far end, which would be called the vertex, and the right far end. Vertices occur at the widest end. Co-vertices occur at the smaller end. So we have a major axis and a minor axis. Because it's ellipse, we don't say radius. Because a radius is supposed to be the same all the way around. So this wouldn't make sense if we said, hey, the larger radius, the smaller radius. But instead, we'd have the major axis and the minor axis, or in this case, the major axis, and this is the minor axis. A is the distance from the center to the vertice, which is on the major axis, and this would be also a distance of A. So this is A, this is A. The total length would be 2A. And this would be B and B. So this total length would be 2B. And that's what's given you here, all this information. The foci is found by using this relationship. It's kind of like the Pythagorean Theorem. It's c squared equals a squared minus b squared. That's how you get the foci. C is the distance from the center to the focus here. So that's 1, and there is another C there. So 2C would be from focus to focus. And when there's plural focus, you call it a foci. Example 1. It says graph this ellipse. Well, the first thing I can do with this ellipse is I know where it's going to be shifted. As we talked about last class, this is inside, so it's shifted left 2 units. So the center is left 2. This would say up 1. So we go left 2, up 1. This is the center of the ellipse. This tells us our width. We're going to go not 9 units left and right, but you take the square root of that. That is, since it's bigger, that is my a squared. So a, if you think about it, you took a square root. Square roots are always plus or minus. If you don't originally start with it, a would be plus or minus 3, which means I go left 3 and right 3. So 1, 2, 3. Here's a vertice. I'll label that with a V. And left 3. 1, 2, 3. There's my other vertice. Now to get the height of my ellipse, I come over here. This is my b squared. So if you took the square root of that, b would be plus or minus 2. That means from here I would go up 2 units. And I would also go down 2 units. These are co-vertices. So I'll label those CV. Now I could have my ellipse. Draw this out. We'll see how good of an ellipse this is. Hey, it's not too bad. That would be my ellipse right there. To find the foci, you would then use the Pythagorean Theorem. So come over here. I say Pythagorean Theorem is close to it. So to find the foci, you would use this formula. C squared equals a squared minus b squared. We already know that a squared is 9, b squared is 4. So you just plug in 9 minus 4 equals 5. So C would equal plus or minus the square root of 5. So that is roughly like 2 and not even a half. It's a little bit less than 2.5. So if I went 2.5 to the left, I'd get a foci here, and 2.5 right, I would get the other foci there. The reason I know it's left and right is because this is horizontal. It always is on the major axis. So I could include that here. I know it's not shown, but the major axis is on the line y equals 1. It's on the line y equals 1, and it's 8 units across. I'm sorry, 8. I can't add. It's 6 units across. Its diameter would be 6 units. The minor axis is on the line. This one here, it crosses x equals -2. It's on the line x equals -2, but it's only 4 units across in length. So that's how you would find those. Let's look at part B. This time the formula is given to us and it's in this crazy form. So we're going to talk about what we did last class. We're going to first put our pairs together. And they're already in order. So I'm just going to put a blank here for a C. So 4x squared plus 24x. I'm going to put a blank for C. And then I'm going to move on, and then I'll do my y's. Since it's squared, it'll also be in the left. So I'd have y squared minus 10y, and I'll put a blank. And then I'm going to put the singles on the other side. The 3 doesn't have a partner, so it goes over here. Becomes +3. Next thing is you have to factor out anything if there's a number in front of the squared. Now here's what's different. I'm not going to divide everything by 4, because if I did, it'll mess this up. So all I'm going to factor it out is within its own grouping. So I will factor out the 4 from there, which means this value is going to change. So this actually becomes 4 with an x squared plus 24 divided by 4 is now 6x. And then I'll have a, and I shouldn't have put that parenthesis right there. Let me change this real quick. I should have put that parenthesis right here. It's going to be here with the blank. And then I continue on with the rest. So I have a y squared minus 10y with the blank. And then that'll all equal 3. Here's what's different. Because I did not divide out that 4, I don't need to do anything with the 4 everywhere across. So now let's go through and complete the square. Here, I take my 6, I divide it by 2. So when I do that, I get +3. That value gets squared and goes here. So I'm going to add 9. But before we add 9 over here, what we need to realize is actually 4 times the 9 because I did not totally divide it out. So what's 4 times 9? It's 36. That came from 4 times 9. So I got 36 there. Now I go over here to the blue, and I'm going to complete the square again. So twice I'll complete the square. So -10 divided by 2 is -5. I square that, and I get +25. Negative times the negative is positive. There's no number out here, so it's just going to stay as +25. Now I simplify it. Remember, the reason we complete the square is because this makes a perfect square. What are factors of 9 that add to 6? 3 and 3. So this becomes, when we simplify this, this is 4 times. This right here is the same thing as x plus 3 squared. That is x plus 3 times 6 plus 3. If you don't believe me, just go on the side and FOIL that out. You'll get this right here. Now over here, this makes a perfect square, and this one is y minus 5. If you remember, the shortcut is you just look at the number there. That's a +3. That's a -5. This will all equal, and now we add these up. 3 plus 36 is 39. Plus 25 more is 64. Last step. We divide by this number over here. We're going to set this equal to 1. So now I'm going to come back and divide this by 64, this by 64, and this by 64. So this one will reduce. 4 goes into 64 16 times. So I have x plus 3 quantity squared over 16. Plus, this one does not reduce, y minus 5 quantity squared over 64 equals 1. There's my equation there. Now we did all that, and now we can graph. That's what it asked us to do. That's the equation. And so if we wanted to graph, the top gives us our center. We need to go left 3 units. 1, 2, 3. Up 5 units. 1, 2, 3, 4, 5. So here's the center. I'm going to shift this over a little bit. Otherwise, I'm going to run out of space. Now, this says we go, when you take the square root of this, remember, this is now our b squared because it's smaller. If that's b squared, then b equals plus or minus 4. So I'm going to go left 4 units. 1, 2, 3, and 4. And I'll put a point, and then write for it 1, 2, 3, and 4. Put a point. These are the co-vertices. Now 64, this is my a squared this time, because it's the larger number. So this means it's a vertical. This is plus or minus 8 units when you take the square root. So I go down 8, 1, 2, 3, 4, 5, 6, 7, and 8. There's a vertice. And then I need to go up 1, 2, 3, and I need to extend this. Hang on a second. Okay, it just extended it. And then we go up 8 units as well. So now there's my ellipse. It looks something like that. If you wanted to put the other pieces, so remember these are vertices, these are co-vertices. We could say our major axis has a length of 16 because it's 8 up and 8 down. And it would be on the line x equals -3. And then this would be our minor axis. Since we went left 4 and right 4, it has a length of 8, and it's on the line y equals 1, 2, 3, 4, 5. Y equals 5. Now I have this one for you to try.